Hi, Mark. How you doing?
Hi, how are you?
Doing good here. We got a big chapter coming up. Welcome aboard, Joseph.
Good morning.
Nice to see the faces. Well, you guys are always hiding on me. Hi, Sophia.
Hi.
Nobody wants to show their face except Mark. You have to look at my face, but I can't look at yours, huh? Okay. We'll give it just another 30 seconds or so and we'll get started. We have a really comprehensive chapter here if you've bothered to look at it yet. A lot of information. So let me see if I can start by sharing. Huh? Hi, Maria.
Hi.
Hey, we got a little bit of a crowd today. That's good. And that's the end of chapter one. No, I'm only kidding. Okay, we have three separate PowerPoints here. The first one is the longer one. The other two are short, but they all roll together. And here's where we're really going to get into using the knowledge we now have of variable and fixed costs and get into things like safety margin and break even points and scenarios. What happens if we raise advertising and lower the price type things? So let's go back to the basics of cost volume profit analysis, CVP. This is called, as you know now, the contribution income statement. It's not GAAP, it's for internal use. Nobody in the outside world, I don't think, wants to see the contribution thing. But let's understand it. We have 500 bicycles being sold at 500 a piece, making our total sales $500. The sales price is fixed, if you will. The variable expenses are fixed on a per unit basis. We know that there's no variable expense unless we sell a bicycle or manufacture a bicycle. So our variable expenses are 300. Our contribution margin totals 100,000 or $200 per bike. Let's understand that $200 contribution margin, excuse me, that $200 contribution margin flows right down to your net income. Meaning every time racing sells one bicycle, their net income goes up by $200. Okay. And from the contribution margin, we're going to subtract the fixed expenses to get net income. Contribution margin statement. And they're making the point here that the contribution margin better exceed the fixed costs, or we're in bad shape, right? We lose money. Also, if if the contribution margin happens to be negative, you're out of business. You can't make money because every time you sell one, you lose more money. Some people say, yeah, but we'll make it up in volume. No, that's a bunch of baloney. You're just going to go more and more in the hole. So get a good understanding of the contribution margin. And here they're making the point I just babbled about. Each unit sold will help to cover the fixed expenses and profit. Let's continue along here. For each unit they sell, they come up with the $200 in contribution margin. I get the sense they had the same, they duplicated this one, huh? Okay, here we go. How many units does racing have to sell in order to break even? Now, this is going to take us through a few formulas for computing the break-even point. We want to know the break-even point in units and dollars. I'm going to go through the more, what I say, unnecessarily complicated method, and then we're going to get to the slides that make things a lot easier for us. But some of you are math nerds and you kind of like to do it that way, huh? Well, what do we mean by the break-even point? Break-even point refers to sales. It's the number of bikes you must sell to come up with zero net income. Break even, zero net income. And if you want to keep this in the back of your mind, it's the point where the contribution margin equals the fixed cost. So this company makes no money until it sells 401 bikes, at which point their net income would be 200. Break even point. Wow, what did I just tell you? You sell one more bike, and now you're making money, $200. The relationships, cost profit, can be expressed by a CVP graph. If we were in the classroom, I would make you guys prepare the CVP graph, because if you can do that pretty easily, you have a good feel for all of the different components here. So what are we looking at here? We have a fixed cost of 80,000, and that's going to be the same no matter how many units we make. If we make 0 units, we still have to pay the rent. We still have to pay for insurance. There's still depreciation on the products. We probably still have to pay a few security guards. That money doesn't go away. If we sell 200 units, we're going to lose $40,000. And we just saw that at 400, we break even. And at 600, we don't lose 40,000. We make 40,000. So they're giving us a little visual here. Preparing the graph, units on the x-axis and dollars on the y. I get confused, which is the x and the y. I've only been doing this for 50 years. CVP graph. And what we're going to plot at first is our fixed cost, which I believe, I assume they're using the same numbers we just looked at, was $80,000. So there's your fixed cost, $80,000. And it's a flat horizontal line representing the fact that the fixed costs are the same regardless of the activity. Then they start plotting the units. Here they're plotting the units representing total expenses. And we know that the variable cost was a certain amount. I was curious what it was. The variable cost, 400, looks like it was, I don't know, $300. What was it? Come on, Bob, $300. So they're plotting this. Every time they sell one more bike, 300, etc. Notice that it goes in a completely straight line. Here is your fixed cost below the red line. Between these two lines is your variable cost, and here is the total cost. Now, they're going to show us how to get to the break-even point. I don't know what this does for us, looking at the same information. The break-even point. Well, we happen to find out that it's at 400 units when the sales are $200,000. There is our break-even point when they sell 400 units. We're showing this to you. If you like to make graphs, you can come up with the break-even point this way, okay? Break-even point. And here they're just showing you a little arithmetic that's not too tough. Profit equals the unit cost times the quantity minus the fixed cost. They sell one unit at $200 and the fixed cost were $80,000. You lose 78,200. They sell 1,000 of these things. Then you're really talking. You're up to 300,000 minus the 80, whatever. Break-even point where profit is zero. The graph will give that to you. Now they're going to talk about an equation, and this is not a hard equation. Equation method. I guess we all know that sales minus expenses equal profit. Who knew? Sales minus variable expenses minus fixed expenses equal profit. Same thing. Sales minus expenses equal profits. We know that. Sales equal variable expenses plus fixed expenses. Well, that would be the break-even point. Plus profits. We can plot the profit we want in there and make some decisions. Here is the information from Racing Bicycle Company. Here they sold 500 bikes. We know the break-even is 400. Well, they make 200 per bike, right? And they sold 500, so that's 100,000 on the contribution margin line minus the fixed net operating income. Now they're talking about the equation method, and we really do need to get familiar with this, not so much for this chapter, but going forward. Sales equal variable expenses plus fixed expenses, okay? Plus profits. Sales, $500 per unit sold times the quantity, which I think was five. Yeah, there it is right there. Five with plus 300 times that same quantity plus 80 equals zero. Your break-even point. That's one way to figure it out. And here's the formula. Again, I don't think you want to work with the formula when you see what I got up my sleeve in a couple of slides, okay? 500 quantity, 300 times the same quantity gives you 200 equals 80, 400 bikes break even. We can also use this equation to compute the break even in dollars if we want. This was in units. This one is in dollars, where we take the variable cost times the units plus 80,000. Again, it's a formula I don't really think we need. Now, take a deep breath. This is the one I recommend we talk about. Contribution margin ratio. We're going to get to the break even in a moment. Well, obviously, the total contribution in dollars divided by the total sales is 40%. We're earning 40% every time we sell a bicycle. And I believe the bikes were sold for $500, and we get 40% of that. The contribution margin ratio can be expressed this way. The unit cost times the selling price. There we go. That's where we got the 40% here. Now, I'm going to keep going because I don't think this is too tough right now. But jump in if my New Jersey accent is getting to you and I'm going a little too fast, okay? Contribution margin ratio. We just figured that was 40%, huh? Well, each dollar increase in sales revenue results in a contribution margin of 40%. 40% times 500, that's 200 per bike, remember? What if we increase the sales by 50,000? What's going to happen to the contribution margin? I'm guessing 20,000, but let's see. Here we go. We were break even at 400 bikes. Now we sold another 500 bikes for we sold a total of 500 bikes, 100 more. Sales are now 250. The variable costs are 60%, remember? And 40% was the contribution margin. The variable costs will go up in the same proportion as the sales. The sales are always variable. and variable expenses go up the same way. So by raising the sales to $50,000 more, we earn additional income of $20,000. A $50,000 increase. We know that the margin, the contribution margin percent is 40. That's not going to change at all based on volume. Contribution margin has nothing to do with volume. We're always thinking about variable costs and contribution margin on a per unit basis for the most part, okay? When we're talking fixed expenses, we're talking a pile of dollars. We don't talk $8 per unit for fixed expenses. That doesn't really come into much analysis. Contribution margin each. Here we go. This is all you need to come up with the break-even point, unless you like to use those formulas, unless you want to put a big map on your bedroom wall and put a giant graph and draw lines. This is the way to go, okay? The contribution margin is this formula. Fixed expenses by the unit contribution margin in dollars, which I believe was 200, gives you the break-even point in units. Our fixed expenses were 80, if we're working with the same numbers, hopefully. And we know it's $200 contribution margin. That gives you the break-even in units. How many more units do we have to sell to break even? Break even in dollars is the same formula. Fixed expenses, except we're expressing the contribution margin as a ratio. So that would be 80,000 divided by 0.4, if I remember correctly. So these are easy formulas to work with. Now, suppose the company does not want to break even. Guess what? It wants to make money. They want to know how many bikes they need to sell to earn a profit of 100,000. We can use our CVP formula to determine this right here. We sell 500 units, 300 here, plus 80, and that is going to give us a, no, I'm just sorry, I want to do this one more time. 500 minus 300, okay, plus the 80,000. We add in the desired income, and it turns out we got to sell 900 bikes. We got to sell 900 bikes. Now, again, this is kind of a longer way to do it. We know that the contribution margin was 200, so let's take a peek. This is the way to do it, guys, okay? The contribution margin approach. You can use this, which I don't like, or this. What was our break-even formula? Fixed expenses divided by the contribution margin per unit. It was 80,000, and we divided it by 200, and we came up with 400. Now, we're just going to add the 100,000, which gives us 180 divided by 200, 900 bikes. Make sense, guys? Any questions? Again, I hope I'm not going too fast. There's a lot in this chapter, but I think it logically flows when you start doing your homework and studying the chapter and perhaps looking at the video one more time. Contribution margin approach. We're back to the famous CVP equation, if you like. Well, this formula here gives us the break even in units. What if we want to know the break even in dollars? Well, we have a hint here. We know it's going to be 900 times 500, right? That's what we're selling them for. but let's prove it. Fixed expenses plus our $100,000 target, that is 180,000 divided by 4, if you will, 40%, 0.40, gives you $450,000. We have to sell $450,000 worth of bikes to earn a profit of $100,000. Break-even analysis. Talk about the variable expense ratio. 60%. 60%. That's going to be 60% whether we sell one or a million. We always think in terms of per units when we're talking variable cost. The variable cost ratio is the ratio comparing it to sales. 300 divided by 500 equals 60%. It can be computed by dividing the variable expenses by the selling price. No difficulty there, I hope. Now, what if we change a few things? And this is what companies do. They're always looking at this stuff. What is the profit impact if they can increase their unit sales from 500 to 540 by increasing the advertising budget? Advertising is a fixed cost. It's not a variable cost. You put an ad in the newspaper, and maybe you increase your sales by 1 million, or you don't increase them at all. It's a fixed cost. You pay the newspaper. So let's go to our model here and see what we can do. Well, one long way to do it, and I kind of recommend you do it this way for a while till you can really grab onto the shortcuts. Well, what changed? They added 10,000 to the fixed expenses. And that advertising drove an increase of 540 units. We multiply out the 270, or rather the 540 times 200, we get 270. The percentage does not change on the variable expenses, nor does the percentage change on the contribution margin. Less fixed costs. Looks like we come up with a profit of $18,000. Should we do this? Is this a good idea, you think? No, it's not a good idea. Our net income was 20, and now we're going to lower it by $2,000. This advertising didn't pay off. We ended up losing money. So we're going to go through a whole bunch of scenarios like this. Here's the easy way to do it once you get the shortcuts going. Well, we know that the contribution margin was $200 per unit. So that's 8,000 additional contribution margin, but the advertising expense was 10. There's our loss of $2,000. I'd love to hear you get to all the shortcuts. When you take the CPA, some of you might, I hope, go on to become accountants and get a CPA license. When you're studying for the CPA exam, these kind of shortcuts are invaluable. Ooh, now we're doing something. Now we're changing the variable cost. What's the profit impact if Racing Bicycle can use better or higher quality raw materials? That increased the raw material cost by $10. Our what's called variable costs have gone up by $10. And as a result of that, we generated more sales. Customers love the increased quality of our products, supposedly. Here we go. 580 times the same amount per unit, $500. Now the variable expenses are not 150. They come out to be 179. after we threw $10 more into the variable cost. It was $300 per unit, now it's $310. So we have a new contribution margin of 110.2 minus 80 equals 30,200. Would you do this? Yes. Net income was 20,000 and now it's up to 30. We got like a 50%, more than a 50% bump. Sales increased by 40 and net operating income went from whatever was before to 10.2. By 10.2, it was 20, went to $30,200. Here's an example of it paying off. What if we change the fixed cost, the sales price, and the volume? Good gosh. What is the profit impact? They cut the selling price, holy cow, by $20, increased the advertising budget by 15, and increased the sales from 500 to 650. So we have a lot of things to consider. Let's take them one by one. The sales price was dropped by $20 to $480. The variable expenses remained the same as a percentage. They didn't change any of the variable, right? No. So the variable expenses proportionately remain the same. The contribution margin is now 117. The fixed costs have gone up 15,000. For advertising, we end up increasing our net income by 10%. We went from 20,000 to 22,000. That's a pretty good bump. Sales increased by 62, right here. We sold more for less, but the volume paid off. What if we change, what the heck did we change here? Fixed sales volume. I'm getting mixed up on all this stuff. What if we change the variable fixed and the sales volume? What happens if they pay a $15 sales commission now instead of paying flat salaries to their salespeople? Well, that means that our $300 of variable expenses are now $315, and currently paying salaries that currently total $6,000. So if I'm reading this right, we're reducing the fixed cost by $6,000 by going to a commission structure, and we increase sales from 5 to 575. Again, that's a lot to go through. Let's take a peek. Well, what did I say? Our variable cost is now 315. We multiply that out, we get 181 here. Remember, we eliminated the salaries of 6,000 from here and increased the sales to 575. Now we're making money, huh? Now we're making money. What that might tell me is that our salesmen were sitting around twiddling their thumbs when they could have been selling. And now that they're being paid on a commission, they're finally getting out and doing their job properly. Change in the sales price. They have an opportunity to sell 150 to a wholesaler without disturbing sales to other customers or fixed costs. What price would it quote if it wants to increase monthly profits by 3,000? Here we go. They are going to sell, the variable cost is 300 each. We're back to our 300. And they're selling them for 320. So we have 150 times 320. The total variable cost, 300 times 150 is 45,000. So the increase is 3,000 in net income. Net income. You can have a lot of these problems on your homework. Okay, we get into some more things, new things, less onerous, I think, than what we've done so far. The safety margin, excess of budgeted sales over the break-even point. It's the amount by which sales can drop before you start losing money. It is this. It is this. It is the total sales minus the break-even sales. Well, we know the break-even sales were 400, right? Break-even sales were 400. Now we have a contribution margin of 100 minus the fixed. Here we have 20,000 safety margin. The margin, I'm sorry, we're looking at the sales. My bad. If the actual sales are 250, the margin of safety is 50,000 or 100 bikes. 100 bikes. Let's take a peek over here, hopefully. The margin of safety can be expressed as percentage of sales. Our break-even sales number was 200. The actual sales needed to generate the 20,000 was 250. So $50,000 is our margin of safety. Not hard. Total sales, not divided by total sales, less break-even sales. This is something companies look at all the time. Are we maintaining our margins properly? Ooh, cost structure. The relative proportion of fixed and variable cost. Managers often have some latitude in determining their organization cost structure. They might have the ability to hire an employee at a higher salary, perhaps, something like that. And I'm not going to get into this too much. They talk about the advantages and disadvantages to a high fixed cost or low variable cost environment. If you have high fixed costs, in other words, if your total costs are $1 million, but the fixed costs are, say, 700, you have an advantage in that income will be higher in the good years with lower proportion of fixed costs. You will have better results when the company is doing good. That's compared to the high variable cost. A disadvantage is, what if the company starts losing money? Well, you're going to lose more and more rapidly, lower proportion of fixed costs. Companies with low fixed cost structures enjoy greater stability in income across good and bad years. The theory is you go with the flow. You lose money, you make money. High fixed asset structure smooths that out. Variable cost, the opposite. Here we go. Let's really talk about leverage. I think you'll find this interesting. Operating leverage, a measure of how sensitive net operating income is when you change the sales. High leverage, if you have high leverage, a small percentage in sales can produce a much larger percentage increase in net income. And this can be very dramatic. So what are we talking about? We are going to take the contribution margin and divide it by the net income. And that is going to give us a number. Hopefully, the contribution margin is greater than the net income. Would pretty much have to be a thriving company. Contribution margin divided by net income gives you 5. That's not 5% or $5 or 5 units. It's 5, just a number. 5. That's your leverage. Now, here's the beauty of the leverage, and I think this will surprise you. With an operating leverage of 5, what if racing increases the sales by 10%? 10 times 5 is 50. With a leverage of 5 and you increase your sales 10%, you're increasing your profits 50%. Pretty dramatic, huh? Leverage. If the leverage was 3, well, that would give them a 15% kicker. The leverage is a very useful tool to have in the back of your head. Operating leverage, they're giving you an example here. What did we just say? The leverage was 5, right? The leverage was 5. So we increased our sales by 10%, correct? This is 500. Now 10% of 250 is 25,000. Add that, we get the new sales number. The variable costs are the same percentage. Our contribution margin went up to was 110. We end up with an increase in net income of $30,000. That's a pretty significant increase. Our income went from 20,000 to 30,000. That's a 50% increase. Operating leverage, contribution margin divided by net operating income. Now we got to think, huh? Coffee Clutch. Well, that's a good name, an original name, huh? Coffee Clutch is an espresso stand in downtown office building. They sell a cup of coffee for $1.49, and the average variable expense is 36 cents, and they've got some fixed costs. 2,100 cups are sold each month on margin. So what's the degree of operating leverage? Well, they sell 2,100 cups, and the contribution margin is $1.33. And we have to multiply these out by 2,100. Let me see the math here. Now, this is one I couldn't do in my head, guys. I'm sorry. 2,100 cups at $1.49. The variable expenses were 36 cents. 36 cents times 2,100. And they told us the fixed expenses are 1,300. What is our leverage? Contribution margin divided by net income. Their leverage is 2.21. If they raised sales by 10%, they would enjoy a 20% increase in net income. How much should the net operating income increase? Looks like the same data. Sales are going to go up by 20%. How much would the net operating income increase? 20%. What's 20 times 2.21? I get 44.2. If there's a God in heaven, that's the answer. Get the hang of it? Leverage, powerful tool. Our leverage was 2.21. We increased 20%, and look what that did to our profit. We increased 44%. You don't believe me? Take a look here. We now sold 2,520 cups. Variable expenses and contribution margin same percentage-wise. The fixed dollars remain the same, and our income went from 1073 to 1548, 44% with the leverage, huh? Part one is done. We have part 2 and 3 coming. Let's go through it. We've gone through most of the class thus far. Let me stop the sharing for a moment. How you doing, Maria? Does it make some sense?
Yeah, it is.
Good to hear. Oh, here it is. Okay, share. Okay. Welcome to part 2 of our amazing adventure. Okay, this is a short presentation here. Let's see what this is all about. Have you ever heard anything called sales mix? Sales mix. A company sells different products, and some products generate more profits than others. You always want to push, for the most part, the products that give you the best contribution margin. Sales mix. Coca-Cola sells regular Coke. They sell this Diet Coke stuff that I drink too much. They sell an orange flavor, a Coke Zero. That's a mix. Maybe they all have different prices with different profit margins. We want to know how to handle that type of thing. Different products, different prices, costs, margins. They sell, this company that we're working with, they sell bikes and carts. How do we deal with it? Here we go. We're looking at the contribution margin again. Here is the company contribution margin for 250,000 bikes. And, well, they don't give you the units, do they? They give us the dollars. That's all we need. The bikes, they sell 250,000 worth. Carts, they sell more total, 550. That's 100%. We take the total variable cost and we get 48.2%. Right here. Shouldn't be too tough so far. Look at the sales mix. These bikes, 250 divided by 550 is 45%. So bikes are 45% of our sales dollars. Carts are 55%. Let's see what the break-even point is in total for the company. Well, we know it's going to be $170,000 divided by 0.482. And there it is. 170 times 0.482. So this company right now, let's see one thing here. So this company right now, their total sales at the break even are 352. How did we get the 158 here? 352,697 times the 45% equals 158. And this is the total sales times 55%. So that gives us something to look at. We now see the contribution margin at the break even for both of these products. The bikes provide a contribution margin of 40% and the carts 55%. So we might say to ourselves before any further analysis, wow, we want to sell carts like crazy. Now, when we're doing this kind of work, they're just making a few notes here. We could have done this in the prior slides. Remember the CVP graph? The selling price is constant. We assume that. And so are variable costs. Variable costs are linear, meaning per unit they are the same, and they will result in a 45-degree straight line. In multi-product companies, the sales mix is constant. That's just just an assumption we're making. And in manufacturing companies, inventories don't change until you produce or sell something. It's common sense. That was a tough bunch of slides, huh? We have one more set. One more set. Allow me to share. Mixed cost. Mixed cost. I think you'll find this interesting. What's a mixed cost? So far, we've heard about a fixed cost and we've heard about a variable. What the heck is a mixed cost? Well, you're going to learn that some costs contain both a variable and fixed element. And they're using a good example here, utilities, electricity. Your electric company charges you whatever this number is, this fixed number, they charge you $100 a month, whether you run any electricity at all. So that's a fixed component. But then when you start using the electricity, they charge you per kilowatt hour. So the cost is going to be the units of kilowatts times the cost per those kilowatts plus the fixed monthly utility charge. And this is an important thing for companies to be able to unwind. How do they do that? If your fixed utilities are $40 and it's 3 cents per kilowatt, 3 times 2 is 6. That's going to be $60 plus 40 on the fixed. That's a classic mixed cost. In terms of analyzing the mixed cost, each unit, each account, either variable or fixed, based on how we believe the cost behaves. The engineering approach classifies costs based upon an industrial engineer's evaluation of production methods and material, labor, and overhead. Boy, that's a lot of talk to say. They kind of know what the mixed costs are all about. Here are different ways to break out a cost. You know that this is the cost per this item, but how do you know which is variable and which is fixed? You're not going to know unless you do a few things. Look at this information here. Maintenance work. Maintenance work at a factory, say. January was 625 hours for, so you can see it varies quite a bit. January, February, it really went up in May and June for some reason. Maybe that's when they had to work on air conditioning. I don't know. And this is the total cost. Well, we can divide 79.50 in January times 625 and get the total mixed cost per hour. But we want to break out the fixed and the variable. I'm just going to show this to you. Again, if you guys really like to fool around with graphs, if you plot this information, dollars and hours of maintenance, and let's go back to that prior slide, and the lowest one was 450, and it went to 850. Let's take a peek. 450, and then it went up, and then it was at 850. Well, if you graph this properly and draw a straight line down to your high to low, that will tell you where the fixed number is. We draw a straight line here, and we're going to end up right about here, I guess. So our fixed cost is around $7,200. Now, obviously, a scatter graph It's not the type of not the type of tool they use at NASA to land a rocket on the moon. You need something much more exact. But the scatter graph is kind of fun. If you're stuck on a problem with a mixed cost, maybe put together a quick scatter graph. Draw your straight line and see how close you come to one of the answers. That might be an easy way to attack a problem, but it's not going to be real exact. Scatter graph. I said scatter graph. There we go. There's your fixed cost. There's your variable cost, total cost. Now, this is a way to get it pretty exact. The high-low method. The high-low method. We're going to pick the high and low of this information and do a simple calculation. We're going to start with the dollars. We're going to look for the highest and lowest dollar amount. The highest looks to me 9,800, and the lowest, I guess, is 7,400, right? You agree? 98 is the high, 74 is the low. We subtract 98 from 7,400, we get 2,400. We're now going to do the same thing with the units. We're going to go for the high and the low. The high looks like it's 850. The low looks like it's 450. The difference is 400. This is the difference in the high-low dollars. This is the difference in the high-low units. And when you divide it out, in this case, you get $6 per maintenance hour. What does that represent? The variable cost per unit. That's how you can come up with the exact variable cost per unit. That's how much the total cost will change every time they work 1 hour. They get paid just $6 an hour, not a good job. But you get the idea? $6 per hour is the variable cost. That's much better than the scatter graph. And here they're showing the calculation. I wish they had done this over here, but that's right. High was 850, low was 450. Start with the dollars, though. Try to remember that. You start with the dollars, 98 minus 74 equals 2,400 divided by 400 is $6 each. Now we can find the fixed cost. The fixed cost. Total cost. I don't like the way they're doing it. Total fixed cost. This is stupid the way they're setting it up. Total fixed cost equals total cost minus variable. I try to say total cost equals total variable plus total fixed. But let's work with these guys, okay? The high, they're just picking this number at random. You could pick any of these numbers now to do the analysis. So it looks like they're going with this number, 9,800 and the 850. Total fixed cost. The total cost was 9,800. The variable was $6 a unit times 850 hours work. There is our total variable cost. There is our total cost, which we were given. The total fixed cost is going to be the difference, 4,700. What if they decided to use not the 9,800, but the 8,275 in March? What if they decided to do that? Come on, this thing's not working. What if they chose the 400 one or a real lower one? Answer is you would still come out to $4,700. If it was 1 unit, you would come out to $4,700, okay? The high-low method gives you the fixed cost. And an important formula to have in your mind, and we're going to be going through this like crazy. Total cost equals variable cost plus fixed cost. Fixed cost is a constant number. The variable cost is this: units times cost per unit. Once you know the total and you know the variable, very simply subtract out to get the fixed. Cost equation for maintenance. Total cost equals 4,700. Variable that we just figured out, fixed rather, plus the units of 600 times $6 times the units. Sales salaries and commissions are 10,000 when 80,000 are sold and 14 when 20,000. What's the variable portion of the sales salaries? Well, we can do this one in our head. The difference in dollars is 4,000, and the difference in units is 40,000. I say the answer is 0.10. It's that easy. 14,000 was the high, 10,000 was the low, that's 4,000. 120 units was the high, 80 the low, that's 40. Here it is. 4,000 divided by 40,000 is 10 cents per unit. Does anybody want to try to do this one? Anybody want to take a shot at this and tell me what the answer is? You're asking for what's the fixed cost? The fixed cost, huh? Well, we just figured out that it's 0.10 per unit. So if we're talking, let's pick the high one. 0.10 times 120,000 is 12,000. I'm thinking the answer is, again, not that hard when you just do a few. And you need to have this in your skull like crazy going forward. We're going to get involved in things like a company is thinking of expanding its factory, and there's all kinds of scenarios. We're going to do this, we're not going to do this. And these kinds of things come in all the time. A scatter graph. I'm not going to show you the scatter graph again. The scatter. You see the least squares regression? If you want to learn that from me, you came to the wrong class, okay? I'm not going to get involved in the math of the least squares regression. Again, you guys might be real good math students and say, man, that's the way I'm going to do it, huh? Doing the regression line, okay? And that's the end. Does anybody have any questions? Any comments? Any thoughts going forward? No? How about you, Sophia?
I
What
think
do you
I'm
think?
doing okay right now. Thank you, though.
You feel like you're able to follow it?
Yeah, I think I was.
Okay. How about you, Mark?
Yeah, I was following along.
It's quite a lot. And I'll ask Joseph, are you lost, Joseph, or you feel like you're going to be able to conquer this?
No, I understand it. It was really good to follow. I liked it a lot.
Yeah. You can tell I have a little bit of enthusiasm for this class. This is the kind of crap I did my whole working life. For a long time, I was the controller of a manufacturing place in downtown Los Angeles, and I loved that job. I was there quite a while. And we did our budgets and our safety margins. We're always looking at this kind of stuff. So anyway, goodbye, everybody. I'll get this video out to the rest of the class. and we'll hopefully see you next Wednesday, okay? Remember, I tutor from 5 o'clock West Coast time for 2 hours on Sunday. If you're doing your homework and you're stuck, you know where to go, okay? Take care, everybody. Bye-bye.
Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.